A matrix as such consists of a row and a column. AB is a row and AC is a column. Now that we know that a matrix consists of a column and a row, we'll move on to how to multiply two matrices. In order to multiply two matrices, you need to multiply the row of the first matrix by the column of the second matrix. So in this case, it would be A times E plus B times G, and its new position would be on the top left corner. If you were to repeat that for the rest, CD would be multiplied by EG, come to the bottom left, AB multiplied by FH will give you the top right, and CD times FH will give you bottom right. Here are two matrices, matrix A and matrix B. Matrix A can be known as a 1 by 2 matrix, and matrix B can be known as a 2 by 2 matrix. If you can see the pattern, the first number tells the amount of rows there are in the matrix, and the second number tells you the amount of columns there are in the matrix. Therefore, A being 1 by 2 and B being a 2 by 2. Not all matrices can be multiplied together. A can be multiplied by B. However, B cannot be multiplied by A. In order to figure out whether a matrix can be multiplied by another, you have to compare the first matrix's amount of columns and compare it to the number of rows that the second matrix has. If these two numbers are the same, which it is in this case, means that the two can be multiplied. However, if you were to reverse that to be B and A, and you place the amount of columns and the amount of rows next to each other, we can see that the amount of rows that the second matrix has is not equal to the amount of columns that the first matrix has, therefore making it incompatible, making BA not possible. How do we find the inverse of matrix A? First off, we have to start by finding the determinant of A. We do this by multiplying A and D, then minusing it by B and C. Now that we know how to find the determinant of A, we'll show you how to rearrange the matrix to find the inverse. You swap D and A, and you change the sign of B and C to look like this. Now, you multiply this by the reciprocal of your determinant.
In this example, to work out the determinant, you multiply 0 and minus 1, and then minus that by 2 times 3. The determinant now equals minus 6. You then rewrite the original matrix like so, swapping the 0 and minus 1 and changing the signs of 2 and 3. You then multiply the new matrix by the determinant.
Something else to note is the order in which matrices are carried out. If a matrix were to be considered a transformation and the question gives you a matrix product of A, B, and C, you wouldn't carry out the transformations in this order from A to C, but instead in the opposite order from C to B to A. So carry out this matrix transformation, then carry out matrix B's transformation, and at the end, carry out matrix A's transformation.